Hello friends, so how are you? So today we are solving this problem, fraction, addition and subtraction. So in this question we are given this kind of expression, okay, where these are the fractional way, right, with the sign. So 1 by 2 plus this is minus 1 by 2 plus 1 by 2. Okay, so basically as per given in the question, all the fractions are irreducible. Okay, irreducible in the sense like we just cannot further, there is no common factor in the number and its denominator. For example, you will never find something like 4 by 8. Okay, because this is reducible, we can still make it 1 by 2, right? So you will find only this kind of thing, okay, which cannot further be have a common factor. So all the numbers would be irreducible fractions. Now we have to evaluate these expression and we have to return what would be the output, and this should be in the terms of fraction only. Okay, so in case if it is 0, still we have to return it like this, 0 divided by 1. So basically we have to return in this fraction way only. So let's go for our approach, guys. So as you know that how to do a sum of them, right? 2 by 3 plus 3 by 4. We know we go the this cross multiplication, right? So we can do this like if I multiply 2 and 4, so 2 into 4 plus 3 into 3. Okay, so this would be plus 3 into 3 divided by what? Divide by whatever denominator we have, multiplication of them. So 3 and 4, right? So divide by 3 into 4, right? So this will give us the solution of it. It would be 2 into 4, it would be 8, 8 plus 9, so 17 by 12, right? 17 by 12. This is the way to solve this kind of things. Similarly, if there were one more number, we could have gone in this way, right? So let's take one more number. Suppose we have one more number, minus 7 divided by 6. So this we already did we already calculated, right? So we can write it like 17 divided by 12 minus 7 by 6. Okay, so again what we will do, again we will do the cross multiplication. So it would be 17 into 6, so it would be 102, right? 102 minus 12 into 7, this is 84, right? This is 84, and divide by 12 into 6, what it is? 72, right? So you'll get 72. So finally the answer would be, answer would be 18 divided by 72, right? But our answer should be irreducible, right? So what would be the GCD of these two numbers, 18 and 72? So go back to school days. You know that 18 and 72, if we look at normally it would be 18, right? Because 18 is the greatest number which would be divide both of them. So what we will do, whatever we have number, so 18 divided by 18 means the GCD. So this would give us 1, right? So this will give us 1, and similarly 72 divided by GCD, so which is again 18. So this will give us 4, right? So our answer would be 1 divided by 4. So why I was giving this solution, because this would be our code approach as well. Okay, so guys, as you can observe that whenever we are coming to any ith step, okay, we need the previous number, okay, whatever number came, to multiply the ith denominator, and similarly we need the denominator of previous step so that we can multiply this with the current number. Okay, we need these two variables, right, at every step, right, just for that approach, the one which we have already followed. Okay, so in this approach, if we keep on going, we need this upper value sum divided by all the denominator multiplication. This is what we were doing there, right? So we need those two variables. So how to start, because this is very first, right? So if we make it dummy start, so in dummy start what we can do, we can put a 0 here and we can put a 1 like this. Okay, so 0 divided by 1, if I making a sum of 0 divided by 1, it is not creating any problem, right? This is 0 only. So for that reason we can start with 0 divided by 1. So what we are doing basically, we are taking two variable. So num equal to, we are starting with 0. Okay, so num equal to 0, and denominator, so we will call it denum equal to 1. This is what we are starting. Okay, so denum equal to 1, these two values. Now our task is to multiply. Now we will proceed ahead from there, right, like this. So what we will do is, so see here, we are starting num equal to 0 here, and denum equal to 1. This is our dummy values. Okay, now what we are doing here, num equal to num into cardinum. See here, this is our num, right, and this is our cardinum, this red icon, right? This is the denominator. Okay, so once we are here, this guy would be our cardinum, the one which I just make it red here, and then we are adding this carnum, so this would be carnum. Okay, so carnum would be this 2, right? This carnum has to multiply with the denum that we started, right? See here, so we are making the multiplication of this way, right? So we would be updating this num like this, and denominator is basically we will keep on multiplying. So denum into cardinum, so whatever current denominator we are coming, 3 in this case, like 3 into 1. So we will keep on putting these values. Okay, so finally we will get numerator and denominator both, right? So see here, initially we have 0 and 1. So let's go here. So this is carnum. Okay, this is carnum, which is 2, and denominator is 3. So what would be the value of num here? So we will calculate. So num equal to what? Num equal to, basically it is 0, right? And denominator is we have 3, right? So then we have to make the plus. Carnum equal to 2, and denominator equal to 1, right? We started with 1, so into 1. So what is the final value? It would be 2. Okay, so this would be our num value. So our new num value is 2. Now come to this denum. So denum equal to denum into cardinum. So 1 into cardinum is 3, right? Oh, this one, yeah, cardinum is 3. So 1 into 3. 1 into 3 is 3 only, right? So our denum would be, new value would be 3. Now we are till here, fine. Okay, now we'll go to the next value. So come here, this time we are reached here. Okay, 3 by 4. So let's calculate this value. So our num equal to 2. So we will make it this formula. So 2 into denominator. What is the denominator? Denominator here is 4. Right, this one. So we will make 2 into 4. Okay, then we have to make the plus of numerator. Numerator is what? Numerator is 3, right? So we will take 3 here, and we will multiply it with the denominator. So what is the value of denominator? Denominator is 3 here, so 3 into 3. So what will be the total value? It would be 8 plus 9, which is 17, right? So our num is 17, new value is 17 here. Okay, we have put it 17. Now come to for denominator. So denominator would be what? Current denominator is 3. Okay, previous, yeah, this previous is 3, and the new currently value is denominator is 4. So 3 into 4. So this would be 12, right? So our new value would be here 12. Okay, now we have this thing 7 and 6, right? So we will proceed for this one. So 17 is current value, right? So num equal to 17. So we will evaluate this value. So let's go for 17 into, what is the denominator? Denominator is 4, right? So we will multiply with 4 plus, but num here is sorry, this is 6, right? So let me correct it. Yeah, so because we are at here now, so let me change the color of it. Okay, yeah, so then we will proceed. I had 17 into, what is the current value of it? Denominator, it is 7, right? We were here, so it is 6. So num into 6. Okay, we are going like this. So num into 6. So 17 into 6. And because this is minus, so this will go to minus. So kernum is minus 7 into denominator. What is the value of denominator? It is 12. Okay, so we will make it 12. So what is the final value of it? The value of it is equal to 102 minus 84. So which is equal to, this is 18 basically. So we will write it 18. Yeah, so our new value of numerator would be 18. Okay, now we will calculate of the denominator value. So what is the previous value? It is 12. And what is the current denominator here? It is 6. So it would be denominator, new denominator value would be 12 into 6. So it would be 72, right? So we are getting here 72. Now finally we have got these values, right? We have got the numerator as well as denominator. These are the two values that we were looking for. Now our answer should be basically 18 by 72, right? But the thing is, these values are reducible. Okay, we can further cut them, right? So for that reason, what we should do is we should get the GCD of these two numbers, like GCD of 18 and 72, which is 18 only. Okay, so what we have to do is, now we have to deduct with the GCD. So GCD is 18, right? So we have to deduct both these values. First of all, we will divide 18 by 18, right? So this will give us 1. Then we will divide 72 by 18. So this will give us 4, right? So 1 by 4. Now this is irreducible. So this should be our answer. Okay. So this would be our approach. Now this is what we have to do once we have the all these things, numerator and denominator. But we are given one string, right? So we will just do a simple dry run of that string as well. Just some if else conditions we have to take care. So let me take one example for that as well. So a string would be something like this, right? So we will start with single traversal. Okay. So in this single traversal, what we will do? First of all, we will check wherever a sign is coming or not. Okay. So in this first case, we are going as it is. Okay. So I'll show you what part of my code as well. So here, whenever we don't have any sign, okay, that means there should be by default this is plus, right? Very first time it would be plus only. Okay, so when we will go in this way, what will happen? Till the time these are is digit, let's say it was 21 divided by, let's say it was 23 divided by 3, something like this. So till the time it is digit, like with this is 2, so 2 is digit, right? Then we are coming, this is also 3, so till the time we will keep on going, right? And we will use that formula, cur into 10 plus cur, right? So we can use whatever we have, char minus 1, char minus 0, cs minus 0. This formula I think all of you knows. So using this formula we will get the whatever value, like 23 in this case. Now what will happen when we will reach here? This would be our slash. So we will keep on going. One skip, we will make I plus plus if I is our iterator. Then again we have to check, because once we are done with this, this would be our numerator, right? So after numerator, once we are done with the numerator, there would be one slash, and if we skip this value, then again we have to use similar method to get the denominator, corresponding denominator, right? So similar way we will go proceed ahead like this. Only thing is, if sign is negative, in that case whatever value we are getting, we have to multiply them with minus 1. Okay, so that things would be negative. Okay, like this, minus 1 into num, if in case this is a negative sign. Okay, only this thing. So let me show you it in my code. This will make it better clarification. Otherwise I would be explaining each and every line of my code here. So first of all, I have written one method which is to find the GCD. So see here, let's say take an example of 4 and 8. Suppose we are finding 4 and 8 GCD. So see what it is doing. If a equal to 0, so if first element is 0, then we are returning b as answer. Otherwise what we are doing, we are returning the same function b%a and a. Now you might have say that how can you say directly? So there is a reason. For example, if 4 and 8 is our call, right? So we will replace, because this is not 0, so we will replace this as 8% 4, 8 modulus 4 and 4, right, according to this method. So what is happening here? This time it would be 0, right, because 4 2s are 8, right? So 4 and 0 and 4. Now this condition is satisfied, so that is why 4 would be our answer. So same, this is the GCD simple method. We can take one more example. Let's say 4 and 8 is a favorite kind of thing. Let's say we are taking 3 and 17. Suppose 3 and 17, nothing is common, right? So what we will do? This is not 0, right? Then what we will do? We will do this 17% 3 and 3, right? 17% 3 and 3. So what it would be? It would be 2 here, right? 2 here and 3 here. Again, this is not 0. So again, we would be replacing it 3% 2, which is 1, right? So 1 and 2 like this. Now again, we would be replacing it. So 2% 1. So 2% 1 always gives a 0 remainder for every number, right? And 1 would come here. Now in this case, this condition is getting fulfilled. So answer would be 1. So you can verify this is 1 only. There is nothing common in 3 and 17. Only 1 is the GCD, which commonly divide both of them, right? So in this way we have written this GCD method. Now come to this part. First of all, I am getting the length of expression, whatever expression is given to us. I am just declaring these values, right? Num and denum, the one which we started, right? So num equal to 0 and denum equal to 1. Now what we are doing, while I is less than n, obviously this is we have to make the condition. Now see here, int sign equal to 1. I am taking positive as 1 and negative as -1. Okay, so see here, first of all I am taking whatever character we are encountering very first time, and we are taking this char num and char denum I just declared. Now first of all I am checking here if ch equal to minus or plus. That means we have to check for the sign, right? So if this is minus, then we are making sign equal to -1, and we are making I plus plus, because in this case we have to start from the next character. Okay, so now we will proceed ahead here. Now you might have a question that when we are starting with any expression, for example here, there is no positive or negative for the very first time, right? So you can see in the code that even when there is no positive or negative very first time, we are not going into this loop, right? So our I is also not getting increased. Okay, so we are not going for very first time because it is given as it is. Plus is not given explicitly for very first character. So in this case we are not going into it. That means our I is also not getting increased. That means we are starting from a digit only. Okay, so now come here. So we are checking while I is less than n until the time it is digit. For example, something like 1 2 3, till that time we are keep on going. Okay, and what we are doing, kernum equal to 10 into kernum. So let me explain it why it is. So for example, we are at this plus, right? Then we will start these things, right? So initially what we are doing, kernum is 0, right? So kernum is equal to 10 into kernum. So it would be 1, right? First of all, it is 1. So it would be 0 into kernum, which is so 10 into kernum, which is 0, plus what is the char at I? So this is 1, right? So 1 minus 0, so this will give me numerical value. So this time it would be 1. Okay, then 2 is also digit, right? So we will still keep on going. Now this time kernum equal to 1. So 10 into 1, it would become 10, right? 10 plus this is 2, caret I is 2. So 10 plus 2, now it will become 12. Now it will further go, but this time it would come here, which is a backslash. So now because of this is a slash, our thing would be stopped, right? So this would be our value 12. So for that reason we are using in this way. Now we are making I plus plus here, because when we were stopped here, that would be a slash, right? So for that reason we are stopping, we are increasing one value, because slash is not our interest. Now from next word on, from next character onwards, it would be the denominator value. So again we are using same function, right? And we are keep on increasing. Now see here, we are making this that same thing, num equal to num into cur denum plus denum into cur num, just that cross multiplication, right? And here we are updating denom equal to denom into cur denom. So now after doing this all, we will keep on going and finally we will come out of it. We would have our value. Okay, now see here, this is important here, that once we have got our num and num and denom, what we have to check? We have to check whether is there any one of them is negative, because any one of them is negative, that means our final answer would be negative. So for example, here I am taking one Boolean variable sign. So if one of them is negative, then it would be positive. Sign would be true. Okay, true means it would be negative. So now see here, and whoever is negative, I am making them positive, because we have taken already the record of sign. Whatever sign it would be, we will later use it. And now here I am making all of them as positive. Now we are taking the GCD value, the same that function which you already used. Now we are dividing numerator and denominator by the GCD. And finally see here, if sign is negative, then we are appending, initially we are putting this minus sign, and then num, and this divide sign, and then denom. If it is not negative, then we are taking the positive value only, and we are returning it. So let me execute my code. And let me try to submit it. Yeah, so it is 84.86 faster, and we are doing O of n time complexity, because we are doing only single traversal. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.